Assalamualaikum everyone and welcome to my presentation video. So my name is Muhammad Syafiq bin Muhammad Rozi and I would like to introduce our mini project for pilot plan 2. So this is our title, which is Manjung Coal Fire Power Plant. The Manjung Power Station, also known as the Jana Manjung Power Station or the Sultan Azlan Shah Power Plant. It is a 4,100 megawatt coal-fired power station in Perak. Alright, Manjung coal-fired power plant is post-completion of construction. The project got commissioned in September 2002. Alright, Manjung coal-fired power plant is located in Teluk Rubiah Beach in Perak, Malaysia. The project is currently active. It has been developed in multiple phases. Alright. The project was developed by GE Power and it is currently owned by TNB Jana Manjung Sendirian Berhad with a stake of 100%. Okay, it is a steam turbine power plant that is used for base load. The power plant runs on dual fuel. The primary fuel being used to power the plant is subbituminous. In case of shortage of subbituminous, the plant can also run on bituminous. The fuel is procured from Lekir Bulk Terminal Jetty.
Hello, my name is Muhammad Afiq. So I will explain about the process flow of this coal-fired power plant. So this coal-fired power plant was located in Manjung, Perak. So for the basic operation of coal-fired power plants, the coal-fired power plants produce electricity by burning coal in a boiler to produce steam. So the steam produced under great pressure flows into a turbine which spin a generator to create electricity. So the steam is then cooled, condensed back into water and returned, or we call recycle, back to the boiler to start the process over. So this is the basic operation of coal-fired power plants. So on this slide, it shows the process flow diagram of the 1000 megawatts coal-fired power plant, which is located at Manjung, Perak. So I will briefly explain about the process flow of this plant. So surely for this plant, coal is used as fuel in the boiler. This huge power station have flash boiler, steam turbines, and generator. Fire tube boiler are used to provide the initial heating of the power plant steam system. So the heat generated from the water tube boiler is used to change the state of water to steam. And the steam is discharged to a condenser steam turbine. The steam turbine that was connected to electrical generator produce the alternating current that passes through switchgear and distributed to an electrical transformer. The generator step-up transformer, or GSU, increases the output voltage to match that of the power grid. Then that is how the electrical produced from the coal-fired power plant. Thank you.
Hi, Assalamualaikum everyone, and it's my turn now, and my name is Nur Safika binti Azmi, and I'm going to explain a bit about the function of steam generator, refrigerant cycle, reaction turbine, and also the compressor. Here is the first equipment that we have, which is steam generator. So basically, steam generators are large cell and tube heat exchangers containing several thousands of tubes. They transfer heat from the primary reactor coolant to the secondary side to produce steam, which then powers turbine generators to produce electricity. Alright, for the next equipment is refrigerant cycle. So far, the refrigeration cycle will start and ends with the compressor. Okay, then the refrigerant flows into the compressor where it compresses and pressurized. At this point, the refrigerant is a hot gas. Okay, the refrigerant is then pushed to the condenser, which turns the vapor into liquid and absorbs some of the heat, as we can see in this picture on behalf of the outdoor phase. The refrigerant then proceeds to the expansion valve or expansion device, where it expands, losing pressure and also heat. and then turning into the indoor phase, the refrigerant coming out of the expansion valve in cold condition and slow due to the loss of pressure. It enters the evaporator in a liquid state where the exchange of heat takes place, thus cooling the load inside the refrigerator. Okay, as the gas cools down the load, it absorbs the heat which turns it into the gas, and the gas is then pushed back into the compressor where it can start the cycle again. So guys, here is the third equipment that we have, which is reaction turbine. As you guys know, reaction turbines are the turbines that use the pressure as well as the velocity of the moving water to rotate. Reaction turbines are placed in the water stream where the water enters the casing tangentially. After rotating the blades, the water actually leaves the casing of the turbine. So we have franchise and propeller types of reaction turbines. So last but not least, the equipment that we have is compressor. So basically, compressors are used in many applications, most of which involve increasing the pressure inside a storage container, such as compression of gases in petroleum refineries and also chemical plants.
Okay, Assalamualaikum and good evening. So my name is Muhammad Syafnan bin Mabarif, and I will explain about the important component of steam plant, refrigeration cycle, reaction turbine, and compressor. So for the steam plant, the first component that used is coal, because we need coal to be burned, and the boiler burn the coal to produce steam. From the boiler, the high pressure steam pass to the superheater, where it is again heated up to its dryness. So for turbine, the steam supply used to rotate the turbine to produce electricity from conversion potential energy to kinetic energy. Okay. So for refrigeration cycle, uh, some amount of the steam left from the turbine will go to the condenser to convert it from vapor to liquid. So it can get cool, then it is pumped to economizer, enter the boiler for repeat the cycle. Okay, for reaction turbine, the role of steam turbine is to convert the energy from the hot steam generated by the boiler into rotation energy over several stages. So the steam is heated back up in the reactor and flows through the intermediate pressure turbine into the low pressure section. The electricity produced by other power source, so it can convert it into highly pressures, compressed air and store for later use. When the energy is needed, this compressor air is then released into turbine generator, so it can be used as electricity again. I think that's all from me. Thank you.
Hello, my name is Nur Arini, and now I will explain about the non-destructive testing or NDT applications that can be implemented in the plant that has 4 units in it, namely the steam generator, refrigeration cycle, reaction turbine, and a compressor. For steam generator, an NDT application that can be suggested is using ultrasonic testing. Ultrasonic NDT works by generating high-frequency sound waves that are used to map surfaces. With the help of the map, technicians can inspect for corrosion and identify other problems with the tested equipment. There are 3 types of ultrasonic probes, which is linear ultrasound probe, convex ultrasound probe, and phased array ultrasound probe. But the most suitable ultrasound probe to be used in this plant is a phased array ultrasound probe. It is because this type of probe can reduce inspection time by eliminating the need for mechanical scanning. By doing so, it will increase the reliability of the measurement by eliminating changes in coupling. Let us move on to the second unit in the plant, which is the refrigeration cycle. As we all know, the refrigeration cycle consists of 4 main working parts. We will look at 2 parts that have been the source of leaks in the refrigeration cycle, which is the evaporator and the condenser. Leaks can be difficult to detect immediately in both parts, as the leaks could be too small to be noticed during a visual inspection. Thus, the most suitable NDT that can be applied to both parts is eddy current testing. This type of testing uses a magnetic field to visualize flaws and defects in conductive material such as iron and copper. Eddy current testing can also detect issues that are invisible to the naked eye. While for the other 2 main parts of the refrigeration cycle, which are the compressor and expansion valve, both have different testing. For the compressor, the testing that can be done is a performance inspection, a flow rate inspection, and a sound pressure inspection, as the compressor is known to be a loud machine in the industry. For the expansion valve, hydrostatic testing is a suitable NDT application that can be used, as this test is a good method of finding leak or verifying performance and durability in pressure vessels such as pipe, tubing, and coils. Lastly, for the reaction turbine, eddy current testing can be done to examine the turbine shaft. The inspection of turbine casing can also be one of the applications of NDT.